Children, we are discussing chapter 11 of your book, that is motion and measurement of distances. In this, the topics which we have discussed was the measurement. What is the measurement? Measurement is the comparison of an object, of a physical quantity with respect to a standard unit. That is known as, that comparison is known as measurement. What are physical quantities? The quantities which we can measure easily are known as physical quantities, like mass, volume, area, length, distance. All those are physical quantities which we can measure. Next, we have studied the earlier units of measurement. The rough or the earlier units of measurements were handspan, pace, cubit, foot, or fathom, the stretched arms, that is known as a fathom. Next, we studied why we disobey them, why we discard them, why those units were inappropriate, because those units were not accurate, as well as those units will vary from person to person, as different people have different size of their body parts. So that is why those units were not accurate and not reliable. So we discard them. And then we find the standard international units or standard units of measurement. The unit of measurement which has much more accuracy and will remain same for every person and for every place. Those units are known as standard units of measurement, or SI units, standard international units. For example, mass has SI unit kilogram, the distance has SI unit meters, time has SI unit seconds, and the volume has SI unit meter cube. To write the symbols of those units, we have certain rules, that the unit is always written in small letter, the unit is never followed up by a full stop, the unit is never written in the plural form. So those are certain rules which are related to the writing the symbols of those units. Then we discuss how do we measure the length of an object. To measure the length of an object, we place the left side of a scale equals to the measurement of the object. For example, I want to measure this card, then I have to place the zero of the scale on the left side, on the uttermost left, and I measure the final point here. Suppose that is 5. So this card is of 5 centimeter in length. So that's how we measure the length. First, I place the initial point, that is 0 on the one end, and then place straight scale along with that length. Then the final measurement. This is the final marking of the scale. During this, we have to keep certain precautions in our mind. We have to, take care of certain precautions while using a scale. The first one is placement of a scale. Scale should be placed with the object along its length. If we place the scale at any different angle than the straighter one, then the readings will be incorrect. The correct placement of scale is this, bache. If to measure this card, you place scale like this, then your reading will be inappropriate. So this is inappropriate placement of scale, whereas this is the correct placement of a scale to measure. Next, worn out ends. Sometimes, due to repeated use of a scale, the ends of a scale becomes worn out. Wear and tear occurs on those ends. Sometimes the scale, will get, very fainted. The readings of the scale gets fainted due to continuous use. So in that case, if the ends will get worn out, then we have to start the reading from some other point. For example, if this is the card I want to measure, and I have a scale which has worn out end. So I placed 2 centimeter at this starting point, and let this be at the 6. This starting point has 2 and this one is a 6. So what we have to do, or what I have to do is, for the final measurement, I have to subtract the initial reading from the final one. That is 2 subtracted from 6 will gives us the final reading, that is 4 centimeter is the length of this card when I am using the worn out end scale. Next, position of the eye. Our eyes must be focused exactly above the end point of the measurement. For example, this is the scale. This is the end point. So my eye must be placed here. This is the correct position. If I watch this end point from here or from here, then that will give me, or that may gives me, an inappropriate reading. So the position of eye must be exactly above the end point of the scale. Then we'll discuss the approximation. During certain our life activities, we go with the judgment in our measurement. That judgment in the measurement is known as approximation. For example, during the formation of, cooking of vegetables, our mother approximately put some salt and other ingredients in it. That is not measured in grams or kilograms. During the formation of tea, the sugar put in the tea, sugar poured in the tea is according to its approximation. We do not measure it according to its grams or kilograms, that is its mass. So that is what the approximation is. If I want to go to my school, then I give an approximate idea that I will reach there in 35 to 40 minutes. That is not the accurate time. There may be less time if I drive my car fast, and there may be it will take a more longer time, as maybe there are chances that I found traffic. So that is the approximation which we use in our daily life. Now we will discuss the concept of rest and motion. Rest and motion are two relative terms. There is no meaning of either of rest or motion alone. An object is said to be in rest when that object does not change its position with respect to a stationary object. This corner of the board is a stationary object. If I am standing equals to it, that means I am also at rest and this is also at rest. But if I start moving, then with respect to that end, I am changing my position. That means I am in motion with respect to this end. But if we talk about this board with respect to me and this mic with respect to me, then with respect to me, this mic is at rest whether I am moving or not. चाहे मैं चल रहा हूं बच्चे, चाहे मैं रुका हूं, मेरे और इस माइक के बीच का डिस्टेंस चेंज नहीं हो रहा. That means with respect to that mic, I am at rest, and with respect to me, this object is at rest. Whereas when I am moving, with respect to this end, I am in motion because I am changing my distance. So an object is said to be at rest if its position remains constant with respect to a stationary object in its surrounding. Then that object is said to be in rest, stationary position. Whereas what is motion? An object is said to be in motion if that object changes its position with respect to a stationary object in its surroundings. For example, let us suppose, I am sitting in a car and that car is riding or driving on a road. With respect to that car, I am at rest, but with respect to the outer trees, outer electric poles, I am in motion. If I stand outside the car, then with respect to that pole, I am at rest, and that pole is at rest with respect to me. But if I, sit in the car and I drove the car away, then with respect to that electric pole, I will be in motion. But with respect to the car in the car itself, I am in rest, or I am at rest. बच्चे जब मैं कार में बैठकर जा रहा हूं तो बाहर वाली चीजों के मुकाबले में मोशन में हूं, बट जैसे ही बच्चों में कार की बात करूं तो कार की रिस्पेक्ट में मैं मोशन नहीं हूं. बच्चे मेरे और कार का डिस्टेंस सेम है. So that is why we always say that motion and rest are two relative terms. Next we'll discuss a very, very important topic for your exams, that is types of motion. Motion has several types, bache. The first which we'll discuss is translatory motion. What kind of motion is this? This is a kind of motion when all the parts of an object moves at the same time, is known as translatory motion. Let us suppose this is my whole body, bache. I am moving like this. My upper portion is in the motion, but this motion is not referred as translatory motion. When I start walking on the ground and with respect to that stationary point, I am at motion, I am changing my distance. That is known as translatory motion. When every part of my body is moving, is covering a distance with respect to time, then that motion is known as translatory motion. For example, a child going down a slide. I am pulling a drawer out of the wooden cabinet. A vehicle moving on the road. The spelling of road is incorrect here. It's R-O-A-D. Road. Next. Translatory motion is further of two types. The first one is rectilinear motion. Another one is curvilinear motion. What is rectilinear motion? The motion of an object along a straight path or a straight line is known as rectilinear motion. When an object moves along a straight line, that is known as rectilinear motion. The example is, I am pulling out a drawer that moves in a straight path. I am moving on a straight path, in a straight line, that is known as rectilinear motion. Next one is curvilinear motion. When an object moves along a curved path, then the motion of that object is said to be curvilinear motion. The motion of this car along this straight path. This car is moving along a straight path. This is the example of rectilinear motion. The motion in which an object, that is this car, moving along a straight path, that motion is known as rectilinear motion. Whereas if this car moves along this path, then this path is known as curvilinear motion. This path is curvilinear path. This is a curved path. And the motion of an object along a curved path is known as curvilinear motion. Other examples of rectilinear motion is when we strike a striker of the carom board, then that striker runs in or moves in a straight path. That is a rectilinear motion. When we pulls out a drawer out of a cabinet, you must have a drawers at your home, in your wooden cabinets or in the walls. When you pull out those drawers, then that movement of the drawer is also an example of rectilinear motion. But if I throw this marker like this, then this marker travels the distance like this and falls on the earth. So this distance is curved path. This path is curved. So this motion of this ball or a marker which I hold in my hand and throw it like this is an example of curvilinear motion. So these are certain other examples of rectilinear and curvilinear motion. The second form of motion which we have to discuss is circular motion. When an object moves along a circular path, when an object moves along the circumference of a circular path, then that is known as circular motion. For example, an athlete runs over a circular path. एक इस तरह के सर्कुलर पाथ पर ट्रैक बना होता है बच्चे, और जो एक एथलीट है वो इस पाथ, इस बाउंड्री पर रन करता है. So that motion is known as circular motion. The movement of or the motion of Earth around the Sun is an example of circular motion. The motion of Moon and the satellites. The first satellites released by our India Space Research Organization was Aryabhat. So these satellites, the artificial or the Moon, which is a natural satellite, moves around the Earth in a circular path. So these type of motions are the examples of circular motion. Students, motion of this second hand. This is the second hand which is in continuous motion, bache. This one is the minute hand and this one is the smaller one is the hour hand. Motion of this second hand is this minute hand and this hour hand in this watch is also an example of circular motion. As you can see, bache, this hand is moving along a circular path. So any object which moves in a circular path, that motion is known as circular motion. Next type of motion which we have to study is rotatory motion. The motion of an object is said to be rotatory motion if it moves about a fixed axis without changing its position. जब एक ऑब्जेक्ट बच्चों एक फिक्स एक्सिस के अराउंड घूमता है, that is known as rotatory motion. In certain animated movies or in your pictures, you must have observed a spherical chakra in the hand of Lord Krishna. That spherical chakra is moving in a rotatory motion. आपने देखा होगा बच्चे आर्टिफिशियल कृष्ण के चारों तरफ एक चक्र घुमाते हैं. That is a rotatory motion. The spinner which is present at your homes or houses is moves along a fixed position. बच्चे ये जो स्पिनर है बच्चे ये हमेशा एक फिक्स पोजीशन पर घूम रहा है. So this motion is a rotatory motion. The blades of a fan moves in a rotatory motion. Next, a spinning top, a Gantt wheel. You must have observed in a fair a Gantt wheel over which you sit and that it will take you for certain spinning spins. So that Gantt wheel moves in a rotatory motion. The center axis will remain same and the other parts moves along this path, along this central axis. So this type of motion is known as rotatory motion. Next, wheel of a sewing machine. You must have observed a tailor, sewing machine. There's a wheel which keeps on moving like this. So that also is an example of rotatory motion. This motion of this spinning top is an example of rotatory motion. As you can see, bache, it is moving along a fixed axis. So this motion is an example of rotatory motion. So it is a spinning top which is moving along its fixed axis, and this is an example of rotatory motion. Of motion which we have to discuss is oscillatory motion. When an object moves to and fro about its mean position, then that motion is known as oscillatory motion. You must have observed the motion of a swing. The swing always moves in a to and fro position to its mean position. Let us suppose that's the mean position. So it will go first to and then fro, back and forth, back and forth. So this movement is known as oscillatory motion. The piston of a car always moves like this. So it always moves to and fro around its mean position. Along with that, the pendulum of a clock is also an example of oscillatory motion. To understand the oscillatory motion, you have to do this setup. Tie a ball or a stone with the help of a thread. This is the mean position of this ball. When you allow this thread to move, so this ball moves to and fro, back and forth around its mean position, and this is known as oscillatory motion. To understand the oscillatory motion, you can make this setup at home. Bind a ball or a stone with the help of a thread. This is the mean position of this. When we allow that ball or that bob to move to and fro, then this motion is known as oscillatory motion. As this bob or this ball is moving to and fro around its mean position, so this motion is known as oscillatory motion. Next type of motion is vibratory motion. In oscillatory and vibratory motion, what is the basic difference? In this motion, some part of an object moves around its mean position. some parts will remain fixed and some part are movable. For example, if you hold a steel string or a fine wire string with the help of iron nails, like this. Suppose this is a cardboard. Over this, fits two nails, iron nails, and then this string is allowed to move back and forth or to and fro. So as this string moves up and down from the middle, this motion is known as vibratory motion. The expansion and the contraction. The expansion and the contraction of the chest cavity during breathing is an example of vibratory motion. The next type of motion is periodic motion. As you observed in your school, bache, after one period the other will come, and this will keep on repeating. So just like that, the motion which repeats itself after a regular interval of time, after a fixed interval of time, that is known as periodic motion. For example, pendulum of a clock. After a fixed interval of time, it returns back to its own position, its original position. Needle of sewing of a machine. You must have observed a needle in a sewing machine. It keeps on moving in a fixed manner. It keeps on back at the same position in a fixed interval of time, like this. So this motion is known as periodic motion. Heartbeat of a person will comes up to its normal position in a regular interval of time. The normal heartbeat of a person is 70 to 72 times per minute, or 72 to 80 times per minute. So it's a fixed unit almost. As well as the earth completes the round of sun in 365 days in 1/4 of a day. So that is what the periodic motion is. The motion which repeats itself in a fixed interval of time is known as periodic motion. Whereas the last type of motion is non-periodic, exact opposite to it. The motion which do not repeat itself after a regular interval of time or at a regular interval of time, that is known as non-periodic motion. जब एक मोशन एक फिक्स इंटरवल ऑफ टाइम के बाद दोबारा नहीं होता, उसके इंटरवल में गैप होता है, कभी जल्दी हो गया कभी धीरे, that is known as non-periodic motion. For example, when I am walking, the swinging of my arm and leg. When I swing my arm, that is not periodic. That is repetitive motion. I am keep on repeating it, but still that is not the example of periodic motion. This example is a non-periodic motion. The last topic of your chapter is multiple motion. When an object possesses two or more than two type of motions, different type of motions at single time, at one particular point, is known as multiple motion. When an object shows more than two type of motions at one time, that is known as multiple motion. For example, a person is riding a bicycle on a road, then the wheels of the bicycle moves in a circular path. But the bicycle moves along a straight path, that is either rectilinear, or a curved path, that is either curvilinear. बच्चे जब व्हील घूम रहा है तो वो एक रोटेटरी मोशन है. जब उस व्हील के घूमने से साइकिल चल रही है, वो या तो रेक्टिलिनियर है या कर्विलिनियर. तो दो मोशन एक साथ है. नेक्स्ट, मूवमेंट ऑफ अर्थ. अर्थ मूव्स around the sun, which is a circular motion. Along with that, earth also moves along its axis. So along its axis is a rotatory motion, and around the sun is a circular motion. As well as the movement of earth is also an example of periodic motion. After a fixed interval of time, earth will comes to its place again, that is 365 and 1/4 of a day. So these are the examples in which the multiple motions takes place.